Okay, so can we rely on fossil fuel energy forever? So back in 1956, a geologist, Hubbard, created this Hubbard curve. And this has been the way we kind of think about finite a finite fossil fuel since then, particularly oil. Right? Oil is the black gold that we've been focusing on for decades, for well over 100 years even, right? And so it has a bell. So he predicted this bell-shaped curve. All right, and this bell-shaped curve tells us now. By the way, so first of all, this bell-shaped curve is production, billions of barrels per year produced every year. And he predicted that the U.S. oil production will peak at 1970. Global oil production will peak at 2005. Okay, and he also took into account future discovery. Right? He's kind of looking at what's the proven reserve currently we have. Okay, and then he also taking into account the rate of discovery. What possible reserve we might have in the future, that we haven't discovered yet. But then once you take all that into consideration, right, he predicted that we will have the production will have this bell-shaped curve. So we will reach a peak and then we'll come down here. Now you want to think about why did he predict this? Why does he suspect that it will shape a bell-shaped curve? Why not just a straight line up and then we just keep using oil until it's done, right? Why not a flat? Why not a straight line just going straight up? Well, the idea here is that when you harvest oil or when you extract oil, clearly you're going to extract oil from the most convenient place first. Right, so easy to drill oil wells, right? You'll tap those, very early on. And now, right, after 100 years of oil drilling, right, we are drilling down, in the middle of the ocean, miles down. We're going to Alberta, to tar sand. Right, we're getting oil from much harder and harder places. Right, and so the cost is going to be much higher. Production is going to go down. Right, and that is the idea behind this bell-shaped curve. And also, right, and we talk a little bit about this in chapter 5 when allocation over time as resources become more and more depleted as the scarcity kicks in. Right? There's more and more incentive for individuals, corporations to reserve the oil for the future because it will be more valuable for the future. And so we see this. We see these multiple factors is going to cause the production level to go down. And in a way, you can say that oil will never run out because imagine where the last barrel of oil would be on Earth, right? It's going to be the last barrel of oil is going to be somewhere on Earth where it would be so expensive, so difficult to obtain that it will not be worth it. We would have moved on to something else. Okay, now. So how good was his prediction? Okay, well, so here's updated data to 2010, and this squiggle blue line here, that is the actual U.S. Production, and there's a black bar here, that is the Hubbard curve, that is the prediction he made back in 1956, all right, and 1970, and this is a really good prediction, right? You can almost follows the Hubbard curve completely. Okay. Now, what does this do? What does this? How does this help us? And why are we interested in this? Well, because remember, right? We're thinking about reserve, and we're thinking about what are these emerging economies, or maybe even our economy, what are we going to use in the future, right? So what kind of fuel source will be used in the future? What kind of fuel source will these emerging economies would they choose? Now, if oil is running out, if Hubbard is correct, right, then the nations will have no choice but to move on to a different type of fuel source, maybe renewable. They will have to adapt a renewable energy because oil is running out. Right? However, you see this little kink here in 2010. Okay, that is fracking. So fracking changed everything we know about fuel reserve. Right, you can see here a future projection. So again, follow the brown line here. We see 1990 coming down to 2010, and we see this Hubbard curve, the Hubbard curve theory being proven here. It seems mostly accurate until 2010. Fracking happens, and then boom, oil production oil production dramatically increased, right? Because because we have tapped into this reserve where before we thought it was impossible. Same thing with natural gas. Natural gas even took off even much higher, right? Even much higher here. Okay. If you look at the reserve now again, okay, so let's change in the graph here. This is reserve, not production, reserve. Okay, and so what we see here, right, is the same thing here. Following the Hubbard curve, we see the oil reserve, right, so starting to come down, right, and so production. So we are producing oil throughout this time, and we are depleting the reserve. However, when 2009 or about 2010 come about, right, the reserve increase, right, what we know to be available dramatically increase, right, but dramatically increase. You see this little drop here, right? That is, I'm not sure how many of you remember, back in 2015, oil prices collapsed, right? And oil price collapsed. And so what happened? We stopped looking. We stopped looking for more oil when oil price collapsed. And so now we were still producing oil and consuming oil, so the reserve were being depleted. Okay. All right. But then in I think it was about 2017, the oil prices bounced back, and we went on and find oil again. Right. We went on into to discover more oil, and here lies in the problem. Right. If we want to predict, what is the fuel source that that we will be using, in the next 20 or 30 years, right? Right. And if it looks like if we wanted to find more oil, we can always find more oil now. Then most likely we will be. Then most likely nothing will change. Most likely we will continue to use oil. Right. Same thing with natural gas. Natural gas, we followed the same story. Right. And coming down again, but then in around 2009, 2010, right, natural gas, we discovered a reserve. Right, and it just seems like we can keep discovering more and more and more. Okay, so this is not a very good news if our goal is if we want to persuade these nations, persuade these economies to move away from fossil fuel, because it seems like it is plentiful. What is the biggest factor in fossil fuel production? The economy. Right? If you look here, this is separate. I just thought this was interesting to show this to you here. All right, we see this drop here. All right, this is a monthly oil production. Okay, and you see this the sharpest drop, right? In recent years. Why? What happened? COVID. Right? COVID happened. The economy locked down. The economy slowed down, and production of oil dropped tremendously. It dropped so much that in a projection, now this is the forecast. Who knows what's going to happen, in the next 10 years? But it looks like the projection tells us that we're not going to get back to our peak production anytime soon. Right? So there's one thing to think about. Right? The economy, right, has a bigger influence, more so than policy, right, than any international or national energy policy. Right? When the economy is down, fossil fuel usage and production decreases. When the economy is improving, then the fossil fuel usage increases. Right?